In this video, I'm just going to take up our practice rational expressions quiz. The instructions are similar for every question on the quiz. It's going to simplify and state restrictions. My first step is always going to be to factor the numerator and the denominator. If it's a simple trinomial, I'm looking at what two numbers multiply to c and add to b. So in this case, it's -6 and +3. In the denominator, I don't have a trinomial. I don't have a difference of squares. So I can just look for a common factor. Both these terms share an x. So I'm going to bring that out front, divide both two terms by x. X squared divided by x is x. -6x divided by x is -6. Once I factored it and my numerator and denominator are expressed as products, anything divided by itself, any factor divided by itself is just 1, so we can kind of cancel them out. And I'm left with x plus 3 over x. So that's a simplified form. We just have to state restrictions. In math, we can't divide by 0, so my denominator can never equal 0. And so x cannot be 0, because then this factor would be equal to 0, or +6, because then that factor would be equal to 0. So you've got to state all the restrictions that would make the denominator equal to 0. We've got kind of the same idea for the next two questions. Again, you might notice what we usually like to see when we factor is that my x squared term is at the front, and it's also positive. So I can flip the order of these two and also factor out a -1. So if I factor out a -1, if I divide -x squared by -1, I get +x squared. 1 divided by -1 is -1. And now it looks more familiar. Now it looks like a difference of squares that I can factor. We always want to make things look as familiar as possible. On the bottom, I always want to look for common factors first. If I take out a common factor, I now notice I just have another simple trinomial on the bottom. So on the top, I've got a difference of squares. So it factors to x minus 1, x plus 1. Anytime I have two perfect squares separated by a subtraction sign, that's what I can do. And on the bottom, two numbers that multiply to 6 and add to 7 are just 6 and 1. Once I've factored completely, if it's expressed as a product, I can start canceling out shared factors. In this case, it's just x plus 1. So I'm left with -x minus 1 all over 2x plus 6. There's my simplified form. And then my denominator, well, x can't be equal to -6 or -1. I usually list those restrictions in order from least to greatest. Same idea here. The coefficients reduced to just 4 over 5. Negative over negative is positive. I have 5 x's multiplied together on the top and 3 on the bottom. So I'm left with just 2 on the top. So 3 of the x's are canceling out from the numerator and the denominator. Same thing with the y's. I have 1 on the top and 2 on the bottom. So 1 of the y's on the bottom cancels out with 1 on the top, and I'm left with 4x squared over 5y. As I state my restrictions here, what would make this denominator equal to 0? Well, x can't be 0, because anything times 0 is 0. And I've also got a restriction on y. Y also can't be 0. So that's simplifying rational expressions. The next two questions, we're going to multiply and divide, which really isn't that different. I'm going to start the same way. I'm going to factor. So on the top and the bottom of that first expression, I'm just looking for common factors. So you always want to look for your common factor first, and maybe that's all I can do if there's no difference of squares or no trinomial. There's nothing to factor on the numerator of the second expression. On the bottom, there's another common factor. So the way we multiply rational expressions is just like we multiply fractions, top by top, bottom by bottom. So I'm just kind of jamming these numerators together. 12 times 4 is 48. Then I've got x squared times x plus 6. On the bottom, I've got 3 times x plus 8 times x plus 6. So the order of your factors doesn't matter, but kind of the convention in math is we put our coefficients at the front. Now I just want to simplify. 48 divided by 3 is 16. X squared divided by x is just 1x left. My x plus 6's are going to cancel out, so I'm left with just 16x over x plus 8. Again, I want to state my restrictions. What would make anything along these numerators equal to 0? Well, x cannot be -8, -6, or 0, because 0 would make this x 0, and anything multiplied by 0 is 0. Division is similar. Before I even think about division, I always want to factor all the numerators and all the denominators first. So here I've got two simple trinomials. I can do those each in one step. Again, what two numbers multiply to c and add to b? I've got one more simple trinomial here. Two numbers that multiply to -2 and add to 1 are +2 and -1. So I'm always going to factor, no matter what I'm doing, let's factor the numerators and denominators first. And now the way we can divide fractions is the same way we divide rational expressions. To change this to multiplication, I just need to take the reciprocal, or flip, my second expression, and then I'm just doing the same thing as before, multiplying top by top and bottom by bottom. So I'm going to multiply after I flip. So I'm going to multiply this by x plus 2, x minus 1. On the bottom, I have x plus 9, x plus 2. And then this x minus 3 is now part of my denominator. And now I can cancel out any factors from the top and the bottom. They just divide to be 1. So x plus 9 divided by x plus 9 is 1. X plus 2 divided by x plus 2 is 1. And I'm just left with x minus 1. When I state my restrictions, anything that would ever make the denominator equal 0 at any step in the question needs to be stated. So I've got -9, -2. And then I've also got +1, because at one point in the question, x minus 1 was a factor on my denominator. And then later on in the question, x minus 3 was on the denominator. So I should write down 3 as my restriction. So whatever shows up as a factor in the denominator, you need to make sure to identify that restriction. So that's multiplying and dividing. The next two questions on the back of your practice quiz were adding and subtracting. I'm going to start the same way, just by fully factoring all my numerators and all my denominators. So it's just factoring that simple trinomial. Now, the one thing we got to think about a little bit more carefully or slower when I'm adding or subtracting is I need a lowest common denominator before I can add or subtract rational expressions. So my lowest common denominator is just a product of all of these factors. But if a factor is shared, I don't need to repeat it. So x minus 7 is shared, so I'm not going to repeat it. And then I've also got an x minus 3. So that's my lowest common denominator. In this question, the second expression is already written over that denominator, but the first expression, I need to multiply by x minus 3 on the top and the bottom. And now I have both expressions written over the same common denominator. So I'm just going to rewrite that over one denominator. I have 3 times x minus 3 plus 2x minus 1 all over my common denominator of x minus 7, x minus 3. And now I can just expand and simplify on the top. So I get 3x minus 9 plus 2x minus 1. And then my last step is just, what else can I do on the top? Well, it looks in this case like I can collect like terms. So I've got 5x minus 10, and it's still over that same common denominator. And again, every question, I need to state my restrictions. This would only simplify to this expression if x can't equal +3 or +7. Whatever makes these factors equal to 0. So that's what we need to do for adding. Subtracting is going to work the same way. I'll show you one example like that as well. We just need to find a common denominator before I can do the adding or subtracting. Again, we want to factor as best we can top and bottom. This is not a trinomial. It's not a difference of squares, but there is a common factor. They share an x. And when I divide both terms by x, I'm left with x plus 1. X divided by x would be +1. In the second denominator, I just have a difference of squares, so I have x minus 1, x plus 1. Once it's factored, I can start looking to find my lowest common denominator. So it's going to be every factor along my denominators, but I don't repeat what's shared. So I've got x and x plus 1, and then again an x minus 1, but I don't need to repeat the x plus 1 because that's a shared factor. What do I need to multiply the first expression by so that it's over this LCD? Well, it's missing an x minus 1, so I've got to multiply that on the top and the bottom. What's missing from the second fraction to make it written over the LCD? Well, it's missing that x, so I need to multiply top or bottom by x. So once I've got the same denominator in each expression, I can rewrite my subtraction problem over that common denominator. And then my last step is just to expand and simplify my numerator as best I can. In this case, I could leave it like this. That would be fine. Sometimes or often the etiquette is to kind of organize our work so that the terms are in order of their degree. So usually we like to put that x squared term first, and it's still over that same common denominator. And our last step is just to state our restrictions. Denominator x can't equal 0, and then plus or minus 1. So that's adding or subtracting. Before we add or subtract, we need to find our lowest common denominator. To find that LCD, we need to make sure that we fully factored before we start. The last question on the practice quiz is we're going to prove that these two expressions are equivalent. So we're not solving an equation. We're not trying to find a value of x. We're trying to prove that for any values of x, these two expressions will always yield the same result. So what we want to do, we want to look at these two expressions separately and simplify them, and hopefully they end up as the same simplified result. So I'm going to look at the left side and the right side almost as two separate problems. For the first time here, there's no common factor here, and my a value is not 1, so I've got a complex trinomial. So you can factor that with kind of the method of your choice. I'm just going to show this grid method. So I'm going to put 10x squared and minus 2. I'm looking for two numbers that multiply to a times c, so that's two numbers that multiply to negative 20 and add to 1, add to b. So those numbers are 5 and negative 4. Those multiply to negative 20 and add to 1. So I put those in the other corners of the grid. Now I'm just going to common factor each row and each column. So my first row, this top row, those both share a 5x. The bottom row, those two terms just share a negative 2. The first column, well, those share a 2 and an x. And then the second column, they don't share anything, but of course everything at least shares a 1. So now I've factored my numerator, and I've got 5x minus 2. I'm just reading down that column, and I've got 2x plus 1. There's nothing to factor on the denominator, but I notice again that I can cancel out any shared factors, and I'm left with 5x minus 2. So now we're going to look at the right side, and hopefully that I can simplify the right side, so I'll just copy it down. And hopefully we'll end up in the same place of a 5x and a minus 2. So I'm going to expand and simplify. So I've got x squared plus 8x, subtract x squared plus 3x plus 2. So I'm going to FOIL and collect. I've got to distribute really here a negative 1. I'm subtracting that whole polynomial. So I have x squared plus 8x minus x squared minus 3x minus 2. And now I can collect my like terms. I have no more x squareds. 1 minus 1 is 0. 8x minus 3x is 5x, and then minus 2. So we've proven that for any values of x, the left side is always going to be equal to the right side. They simplify to the same expression. So I can say, therefore, left side equals right side, or I could write that, therefore, the equations or expressions are equivalent. And I just want to state the restrictions from both the left and the right side. The right side had no denominator, so there are no restrictions. But this 2x plus 1 could never equal 0. What would make 2x plus 1 equal 0? Well, x can't be equal to negative 1/2. To get that negative 1/2, you could either set this equation equal to 0 and solve, this expression equal to 0 and solve, or we know this pattern, I'm always flipping my constant and putting it over the coefficient. So either way works. So that's just a quick take-up of our practice quiz. Your actual rationals quiz is going to be very similar questions, but shorter in length. Okay, thanks for watching.